In our previous example, we were solving systems of equations, but we were solving them graphically. Now, solving graphically can be convenient, but it can also be really inconvenient and sometimes imprecise. So solving graphically requires that the system is usually has whole number or integer solutions. For instance, if the solution was like root 3 or 1/85th or something like that, it would actually be really hard to tell just graphically what the answer was. Alright, so it lends itself well sometimes, but at other times it's not really that good of a way to do it. Okay, another way you can do this is a method called substitution. Okay, so let's take, for instance, if I started off with two equations and we'll put them into general form just to illustrate. So let's have, let's just say in the general form is 4x plus y minus 17 equals 0. Alright, and I had another one that was x minus 2y plus 7 equals 0. Okay, so if I had both of these equations, first of all, I'd have to try and put them into slope-intercept form, and then I'd have to graph them, and even then I might not get a great solution. Alright, but let's see what happens. There's a way we can do this just using our equations, and it's a method called substitution. Okay, so what I'm going to do is I'm going to express one of these in terms of either x or y. Now, I'm going to show you using both examples. So I'll do one when I express it in terms of y and the other one when I do it in terms of x. Okay, and then what we do is we substitute that one into the other equation. This is how it works. Okay, so what I can do is I can subtract 4x from both sides here. Okay, and I can also add 17 to both sides. Okay, now these will eliminate and these will eliminate, and that leaves me with y is equal to negative 4x plus 17. Alright, now over on this side I have x minus 2y plus 7 is equal to 0. Okay, however, I do know what y is. Okay, y is 4x, or negative 4x plus 17. Alright, so what I can do is instead of y, okay, I can just cut this out, because I know what y is. Y is this. Okay, and just cut that out and just make a little more room for it. Okay. Okay, and now I have an equation that's only in terms of x. Now, once an equation is only in terms of x, then I can solve for x. And let's see how this works. So I get x plus 8x minus 34 plus 7 is equal to 0. Okay, now x plus 8x is 9x. Okay, and negative 34 plus 7 is negative 27. Okay, and that would be equal to 0. So I have 9x is equal to 27, and x would be 27 over 9, so that would be 3. Now, once I know that x equals to 3, okay, what I can do is I can come back over here where we had found that y is equal to negative 4x plus 17. Right? So what we can do is substitute x back in. So this is negative 4. Now we know that x is 3 plus 17. So y is equal to negative 12 plus 17. Okay, and y is equal to 5. Okay, so the point that satisfies both equations is x equals 3, y is equal to 5. Alright, and this method is called substitution. Alright, now I'll show you using the method where I do it with x here. And we're just going to need to rewrite some stuff here before I erase this. So 4x plus 7, or plus y, minus 17 equals 0. Okay, and we'll just clean up this page here. Okay, so again, we started with this. Now, in the first example, I started by solving for y. This one I'm going to solve for x. Okay, and it doesn't matter which equation you use, but I'm going to use the second equation because I already have a single x all by itself, and that'll eliminate any fractions. Okay, so what I have is I'm going to add 2y to both sides, and I'm going to subtract 7 from both sides. Okay, so then what I get is x is equal to, these eliminate, 2y minus 7. Okay, now I come back over to this equation, okay, and I see that I have 4x plus y minus 17 equals 0. Okay, once again, I know what x is. Okay, so I can just take this, make some room, and just take this and slot that in. Now don't forget the brackets. Okay, that's very important. Okay, so now I can solve this because I have an equation only in terms of y. So I have 8y minus 28 plus y minus 17 equals 0. Okay, so 8y plus y is 9y, and negative 28 minus 17 is minus 45. Okay, equals 0. And 9y would be equal to 45, and y is equal to 5. Right? Once I know what y is, I can come back over to this side and say, because x is 2y minus 7, then I can substitute that y back in. X is equal to 2 times 5 minus 7. So x is equal to 10 minus 7, and x is equal to 3. So the solution, or this point that satisfies both of these terms, then must be the point where x equals 3 and y is equal to 5. Okay, so that's how we do substitution in a nutshell. And I have another video that you can look for that has a few other examples of this. It really doesn't matter which equation you solve for or which order you do it in first, whether it's x or y. It just matters that all you have to do, you just need the two equations. You solve one for one variable and then you substitute it into the other equation. Alright, so if you do like the video, give me a thumbs up, and if you do like my channel, then subscribe, and please look out for my next video, which will be part 3 of solving systems of equations, where we will discuss the process of elimination.